everybody, what's up? Welcome to another video. As you guys may have caught on our last video, we had the RS Buck CNC routed up at the NDSU Innovation Studio. Now we're back here at the shop and I've just made a few minor adjustments and fine-tuning, I guess you would say, to the Buck. Those were primarily in the form of knocking down the cross sections that were proud of the longitudinal sections. So each one of these was standing up a little bit high. Just knocked those down with the hand planer and hand sander just to smooth things out. And then I wire edged each wheel arch. I also whipped up the canopy that you see here just from scratch. I had the windshield that we're going to use, which is from a Porsche 906. And that's kind of what I based that flow of the canopy off of. It's always interesting to look at a Buck in this state because without the metal on, it in some cases is hard to define where things are going to go. For example, sometimes a canopy looks like it might be sitting really high, but in actuality, the way the metal flows in and the window lines are cut in, everything gets proportioned. So as we're going through the video, keep that in mind. Every once in a while you do have to go back and make some major changes because things just look way off, but we've spent a lot of time fine-tuning this. So today we're going to jump into, I guess, what we would call a series on coach building. And this is a video that I've been excited to make for a long time. I know that's the reason a lot of you guys have subscribed to this channel. So the very first thing we're going to do now that we have the Buck back here in the shop to begin the process of shaping is pattern making. And in order to make patterns, we have to understand the material. So we'll jump right into the materials that we're using. We're using 3003, 063, H14 aluminum. The 3003 stands for the grade of the aluminum, and basically that identifies how much pure aluminum content is in the material. A material with more pure aluminum content would be 1100, and a material with less pure aluminum is 5052. 5052 is what you would typically get at your local supplier. Usually 3003 has to be special ordered. 063 is 63 thousandths, that's the thickness. Now, some people prefer to use a thicker material. Usually that requires heavier tooling. There are some guys who shape that stuff by hand, and that's incredible. It's a lot of work. In the traditional days, the competition cars, so post-World War II cars, were 030 and 040, so 30 thousandths and 40 thousandths. Very thin, very lightweight. Put your thumb into it and you'll see a mark, that kind of thing. And then the H14 is the hardness level. That's a mid-range for the hardness. So H0 would be fully annealed, and that means it's dead soft, it's very pliable, in the easiest form to shape. And then the higher number, like H28, would be very stiff, very brittle. And as we're working the aluminum, hammering it, it work hardens and it works its way up into the H20, H22, 24 range. And then we have to anneal it. That's introducing heat to the material to bring it back down to H0, or as close as we can get to that. So that's the material. The reason that I explain the material is because pattern making happens in so many different industries. And in order to make a pattern, you have to understand the material that you're using. So I'm basically going to give you guys a lot of what I teach in my classes here, and I'm excited to do it. All of this is what I've learned along the way. So when I look at pattern making, I think of tailors making suits. And there's a great documentary called Men of the Cloth that I would suggest watching if you're into metal shaping. The parallels are just dead on. So in pattern making for a suit, the tailor looks at the human form and lays out each pattern, just like we do on here over this skeleton, lay out each pattern in a way that complements the human form and makes the best use of the materials, and ultimately all the different patterns flow together to make a beautiful suit, or in this case, a body on the car. Metal moves in two ways. It can be contracted or shrunk, or it can be expanded or stretched. So with the question of where do we shrink and where do we stretch, we have to look at the buck and start to identify these different areas and how the metal needs to be moved. Now, when I lay out my patterns, I typically split a fender right down the middle. So I'm going to do this half and then do that half. But let's look closely at what's going on here. If I'm using this half of my fender, I have basically a point A and point B. Now, if I dissect this from the peak out to the wire edge, which is the bottom of the fender, I have 8.5 inches. And we know it's going to be a longer way around here. I have 9.5 inches. So if I start with a flat piece that cuts down the center of this radius, it's going to be all stretching to get it to come out to that 9.5 inches that I need. Whereas if I were to take a larger piece and come from the outside in, I'm going to be shrinking all that material down. So I'll probably start with more like 12 inches and shrink all that material down, if that makes sense. We're going to do something kind of interesting, and I'm just kind of winging it here, but what I'm going to do is take just this flat piece of scrap and get a shape to the radius here, and then we're going to mark it at both points, at the wire edge and then right up here at the peak. Okay, so here I've marked it as it fits to the radius. Now I'm going to take and mark it here at the peak. We've got the same point, okay, and then I'm just going to put a V on this one. So we're going to run this through the English wheel and wheel it until that V, which right here we can see does not reach the wire edge, right? We're going to wheel this thing just to give you an example of stretching material. Very simple, very straightforward example. Stretching this until it reaches out here. And all we're going to do is wheel this with, of course, the flat upper anvil on the English wheel, and then we're going to put a lower flat as well. And just see how much we can squish this down until the V reaches the wire edge. Let's check it out. So I'm just going to wheel this through, tighten up, just to try to expedite the process. We'll tighten up the wheel a good bit. And you know what else we could do? Let's just throw a micrometer on this to show you guys. We start with 0.63. We're going to see what we mic this down to gain that extra inch. So we'll check what we've got here. You can see 0.063. And I've already gained a little bit, 0.062. So that's just with a couple passes. Looks like I may need to balance my wheels out here a little bit, that's for sure. I can tell because it's putting a bend in the material. This was a straight piece. So let's check if these are off a little. Yeah, they are. There we go. It's an easy way to check how true your anvils are as well, because now it's starting to swing it back and straighten it back out. Could do it even a little bit more. Oh, it's getting thin. Started to make some bad noises. Let's see how close we are. I think it's work hardening, that's for certain. Look at that. So we've gained probably 5/8 of an inch. We're almost there. And let's see how thin this material is. 0.59. So we're getting somewhere. If I had checked the width, I'm sure it's getting wider as well as longer. So from the center of this rib on top. We're right at the wire edge now. So just by stretching this on the English wheel, we've gained a whole inch of length to that panel. My first build was done primarily, entirely actually, with stretching. All the panels were wheeled on the English wheel. And I didn't have the tree stump set up with the dish on top with the bossing mallet for shrinking. So whole car was done through stretching. Now, if we wanted to shrink this back down, we'd have to take the material back in and bring it back down to fit a tighter area. So I hope that helps make sense of the process of stretching with the English wheel. So the process that I use for shrinking, which I've shown in some older videos quite a few years ago, is on the reciprocating hammer with thumbnail dies. The thumbnail dies basically take the material, the dies are moving, the upper die is moving up and down, and as you move material in, it's putting a ripple in it, and as you bring the material back, it's drawing it all to this point and forcing the material back into itself and gathering it together. So as it comes out, it almost looks like a ripple, like the pleat in your clothing. But as it draws it back in, it takes that ripple and forces the material into itself, making it thicker. So that's the process that I use for shrinking on this machine here. But what we're doing today is taking these ideas and applying them to pattern making. So with the idea of shrinking and stretching, I'm filtering all of my pattern making through the tooling that you just saw here. So I'm going to lay this out. When I first started, my patterns or my templates for the panels were small. I just couldn't handle a lot of material. I could only get so much material to flow where I wanted it to go at a time. Now I'm able to get a much larger section of material to flow where I want it to go in one shot. So if you guys are just starting with metal shaping, start small. With this, we're going to start with a longer pattern right here and show you guys how the pattern tells me whether I'm going to shrink or to stretch. All right, so for my pattern, I've just got this lightweight paper. Another material that I'll use for pattern making in many cases is actually aluminum foil because it really tells you a lot. But just for the sake of this example, I'm going to use the paper here. Now, there are two ways that I can apply this paper to the outer half of the fender where I want to make the pattern. When I build my buck, I always like to have a longitudinal section or rib at the peak of my panel. A lot of people build bucks in a lot of different ways, and just a heads up, there are a ton of people offering bucks and files online who have never shaped metal and have no idea what should go into a buck to actually use it to produce metal. There are so many things done with the buck that you see here intentionally so that it works with my process of shaping. And everyone shapes differently. Really, I don't think any two metal shapers shape identical to one another, but this buck was built specifically with my style of shaping in mind. So with that said, I like having a rib at the high point. I like having ribs at the low point. I like having a center rib down the middle, and then it's mirrored on the other side. That works well with how I process my metal shaping. So what I'm going to do with this, I can take my paper, the raw paper, and put it on here in two different ways that will ultimately end up with the same result. I could start from the bottom, this plane here, and work my way up, where I would be doing all my shrinking at the top, or I can start at the top and work my way down. Now, I'm going to lay this over the top and bring in the material, and this will have pleats in it. But those pleats tell me this needs to be shrunk right here. And I take that visual example and apply it when I'm using the reciprocating hammer. I'll also make a note mentally, because what I like to do is hammer out the center section to raise it up with my bossing mallet and the leather shot bag up here on the stand. So I'm always filtering what I'm seeing through those ideas, because that's how I'm ultimately going to shape. I'll start by just taping the upper portion of this, because what I'm doing is looking for where the paper kind of naturally wants to rest. And in that same breath, I will point out that when you start metal shaping, it's usually a wrestling match. You're trying to force things, you're trying to make the metal go places that it doesn't want to go. And it took me like 5 or 6 years before it just a little bit started to turn into a dance, where you're starting to guide the metal, guide the materials where they want to go, and things start to flow more easily. You're not as frustrated. You're not throwing hammers around your shop, that kind of thing. So it naturally wants to lay right there, dancing. Now I've got all of this material out here that needs to be brought in, which means it needs to be shrunk. So what I am going to do is just at about each rib, I'm going to pull down, and you see these wrinkles start to form, and those wrinkles indicate shrinking. So I'll just take the wrinkles and work with them. I'll go with them. One by one, and it tells me what needs to be done. All the information is right in front of you. You just kind of have to know how to tap into it. And in order to know that, you've got to know how metal moves, especially how it moves with the tools that you have in your shop. So now if I were to try to use this much metal to make this piece, if I actually had this much extra material out here, in order to get this to shrink with the tools that I have in my shop, I'm going to have to shrink all the way from out here into here. And that, to get this much material to shrink with what I have here for tooling, is a huge undertaking. I'm going to want to trim what I have here down so I'm not wrestling all of this. So what I just did is identified a wrestling match that I don't need to have. So I'll grab my razor right now, because in my mind I'm kind of working the metal as I'm seeing the paper. And I'm going to trim off all this extra. So I've got this nice rib right here. And it's going to go like that. I will leave myself a little bit of extra, but not nearly this much, because it's too much to try to work with. All right, so that's going to make it a lot easier. Now, if you have a steel wireframe buck, you can use magnets, and it's kind of cheating because you can magnet the paper right where you want it, fold it, magnet. Super easy to do. With the wood, you can use push pins, which I don't have any here right now, but that would make it really nice and simple to pin it right to the wood. But what we do have is tape, so that's what I'm using for the example. And I have taken an entire wood buck and covered it in paper of the original RS actually to get an idea of the flow. And because I was so excited the very first time I made it, I wanted to see just what it looked like. And it actually revealed several areas that needed to be adjusted. So you can do this with the whole entire buck. So when I get back into here, it's interesting because what you think is going to be a ton of shaping actually isn't that much. This isn't a lot of stretching and shrinking that needs to be done. When I get back into here, this panel almost just naturally flows without any shrinking. But what's cool is that on the finished car, it looks like there's a ton of shape in there. So these are kind of the things that you realize and make a mental note of, because this may be an area where as I'm shaping, I think, oh, I need to wheel a lot or shrink a bunch through here, but right now it's just telling me it almost wants to just flow without any shrinking going on back here. So what I will do, I'll put a piece of tape here, and I'll identify this valley of the upper fender flows right back. You can see the low point right here. So that's going to flow down. And I'm going to leave myself a little extra, but this is going to kind of come around. And we'll refer back to the photos, the renderings that we have. But this is going to come around and land. We can see it's similar to the back. It's going to land right in here. And I designed this so that it gets welded to this barrel side. So that'll just flow right into it. So we've got the beginnings of a pattern. Now, I make a seam that gets welded at the peak, like I said. I also do this nose section. There's a separate piece that comes in here and forms around this area. And again, this is flowing out just how it should here, so I don't need to make any major changes to it. Now when I take this and I translate it onto the metal, I'll leave myself a little extra. I can already see I've got a couple extra inches around the wire edge. I'll leave an extra 1.5 inches up top as well, because you never want to run out of material. If you go and you shape an entire panel, I've had it happen, and all of a sudden you're just above your wire edge by 2 or 3 inches, you pretty much have to start over unless you can add a seam in somewhere. It depends on your style of work and your project, but that's kind of a no-no. I like to have uniform seams on each side of the car. And I will also say, with my style of shaping and the era that I have in mind, post-World War II, traditional coach work, they hammered things out fast, they went racing. People today, their shaping, their level of quality is way beyond what was happening in post-war Germany, where guys were just pounding these things out in barns. It was more about getting out and going racing than it was about having every single thing perfect in the bodywork. So people will do things differently today. They'll treat their welds different, finish different, all that good stuff. I kind of have this era in mind, and I honestly, the finish on my work goes beyond the era that I try to capture. To me, it would be fun to go back, like with my very first build, and finish a car like that again, where it was raw. I would love it. So, but this one, we're going to go ahead and take this paper pattern, and now we'll transfer it on to metal, and that'll be it for the pattern portion of this video. So I very carefully will take this over to my material, and we'll transfer the information onto metal. Let's see how it will lay. It's really close right there. You don't want to sell yourself short with your material. So if I lay this, as you see it right here, it's got that full crown, and if I were to draw this out just like this, I'm going to have to do a lot of stretching because, like I showed you in the beginning of the video, I've got whatever, 9.5 inches of material here, but if I measure from here to here just on the material below, it's going to be probably an inch or maybe even less. So that laying it out this way would require me to do a bunch of stretching. So what I'm going to do, if I give this a little bit of an arc across the top edge and draw this out, if I pull this out a little bit like that, I'm going to split the difference. I'm going to give myself both the upper and the lower that I need. And then I'm going to, because I stretched it, I'm going to give myself extra material just down here below the wire edge area. And I'm going to give myself extra basically around the whole thing. But I'm constantly processing, you know, how much extra I'm giving myself. Slight arc there, and this rolled off the edge a little bit. I think I can make it up. So now that we've got a general outline of the shape, I'm going to grab a tool that I find so helpful. It's called an AccuArc adjustable ruler, and that helps me get the flow of the line. Now, it's unfortunate, I believe these have been discontinued. They no longer make them, but this tool allows you to find different radiuses, and it allows you to check your work after you've been shaping a panel. You can put this over the work and find highs and lows. It's useful for so many different things. But I use it to just catch these different radiuses and get things to flow together nicely so my lines aren't all over the place. So that top rib, that's kind of an important line. The bottom, the wheel arc will get trimmed off. So when I got into shaping, I bought the cheapest version of this shear that you can get. And it lasted me like 8 years before it gave up. And at that time, I bought the Milwaukee, the best of the best. And it has never worked as good as my cheap one. This thing, bad tool. Sharpened it. I know you guys say take it apart, sharpen it, put a different jaw on it. This has led to more carpal tunnel in my wrist than anything.
2 hours later.
It's attacking me. Oh man, it's really, really attacking me. So I am a bit on the obsessive side about my material and it getting like any scratches, anything, any dings. You want to keep your material as clean as possible, because if you're leaving a car in raw aluminum, it all has to get cleaned up. So every little nick or scratch is going to be addressed at some point. Now, before I start doing any shaping on this panel, I'm going to trace this onto another piece of aluminum so that we have our opposite side. So with this in mind, we could put this into CAD, these different patterns, and have these CNC cut up at the Innovation Studio and have, 8 of them ready to go. That would be thinking. But because we're old school, we're going to continue to toil, develop arthritis in our hands while we build. No, we won't do that. We'll go to the Innovation Studio. Okay. Now, you can see, taking that pattern, and I can already start to identify what's going to have to happen with this, with the processes of shrinking and stretching. And that is what we're going to show you guys on the next video. So I hope you guys found this interesting. I hope it was helpful. Ask questions, comment, be kind, and we will see you on the next episode. Thank you.